name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goel Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller and embedded systems design having code KEC 061, what we have covered? We have covered our unit number 1 and unit number 2. Now, from this lecture, I am going to start unit number 3. So, these are the table of contents that we will cover in this lecture. First one is introduction to embedded system. We will learn what is embedded system because this unit, half portion of this unit is dedicated to embedded system. After that, we will learn about the what are the various applications of embedded system. After that, we will see the specific example of embedded system. We will take some real example, that is by computer. After that, we will learn about the difference between the embedded systems with the CPU, MCU, etc. We will see that. After that, we will learn about the classification of embedded system. What are the various classification of embedded system we will see in this lecture. After that, we will see the general computing system components used in our embedded system, and we will take some real time example as well. After that, we will learn about the gasoline automobile engine control unit. We will see the its real time example of embedded system components. Now, let us start with the introduction of embedded system. So, in the previous lecture, we have already covered some of the portion of the embedded system. We have seen its introduction. Now, we will discuss in detail. So, what is embedded system? Embedded system means which is a combination of software and hardware, and software plus hardware, and if it will work in the real time, then we can say that it is embedded system. So, basically embedded system is a application specific computer system. Application specific meaning is that it is dedicated to one application. For example, if we are talking about the printer, it is dedicated to one application. It is taking the commands and print whatever according whatever we want to print it out. So, another example is the microwave oven, washing machine. Washing machine can do only a task of washing the clothes. Okay. So, basically embedded system are application specific. They are dedicated to one application. It is built into a larger system. For example, if we are taking here the example of the car. In this car, there are several units of embedded system. There are several units of embedded system. So, basically a embedded system is a part of a larger system. So, we can say that if this is the main system, if this is a main system, then embedded system is a part of it. It do not interact directly with the environment. It is a part of a main system. So, often with real time computing constraint, it means that it works on the real time without any delay. In embedded system, the main feature is that it depends upon it works on the real time. That is real time data collection, real time data monitoring, real time analysis of data is carried out in embedded system without any delay, without any delay, without any delay. So, why we use we can say that why we use a embedded system, why it is a part of a larger system. So, why add a computer to a larger system means that why we are adding the embedded system into a main system to increase the performance, that is for better performance. If we want to carry out the better performance, then we have to include embedded system into a main system. It more functions and features. If we are talking about embedded system, then it has more functions, it provides more functions to the user, and it has a more features as compared to general purpose system. It has a lower cost because it is dedicated to one application, and the components are using according to the application. So, it has a lower cost as compared to general system. For example, through automation, we can say that it has a lower cost as compared to other systems, more dependability and reliability, etc. So, these are the basic features of embedded system. Here you can see the applications, right from the printer to speakers, our smart mobile phones, cameras, cars, various applications of embedded system. So we can say that in any particular application, if we are taking the camera, in camera it is a main system, okay, and embedded system, there are various units of embedded system. So embedded system, we can say that it is a part of the larger system. So in this diagram you can say that if this is embedded system, so we have already seen that embedded system is a combination of software and hardware, okay. So whenever we are giving the commands to the embedded system, so we can say that input from the environment, they are taking the input from the environment, and we are and it is provided output to the environment, okay. So whatever we are providing input to the embedded system, it processed it and provide output according to the input, okay. So there is a user interface as well, and it is a link to other system. Embedded system is a main feature is that it is linked to another system. It is compatible with the other system. At the same time, they are getting the data and provide to the user. Okay. So this is the introduction of the embedded system. Now more about the embedded system. So what is the technical definition of the embedded system? An embedded system is a system that has embedded software in a computer hardware. What does it mean? It means that if we are talking about the hardware is a processor, is basically a IC chip, okay. So in embedded system, we are integrate. Embedded means we are integrate software program into the hardware, and this becomes a particular application of embedded system, and this application work according to our needs. So we can say that in embedded system, software program is embedded or integrated into a software chip, and it works on the real time. Then we can say that it is embedded system. So the system is dedicated. Dedicated means it is dedicated to a particular application, okay, for either an application or specific part of an application or product or a component of a larger system. We already seen that it is a part of the larger system or main system. So in a main system or larger system, there may be more number of embedded system units, okay. For example, washing machine, cooking machine, automatic chocolate vending machines, multitasking toys, all are example of embedded system, okay. Now let us discuss some of the applications of embedded system. There are numerous applications of embedded system. We are not limited to only these applications. Applications are countless, okay. Right from the consumer electronics, camcorders, cameras, household appliances, we are using embedded system, washing machines, refrigerator, more examples we can say microwave oven, geysers, okay. Automotive industry, anti-lock braking system, ABS, engine control system, all includes embedded system, okay. Home automation and security system, we can use embedded system. For example, air conditioner, AC, sprinklers. What is sprinkler? Sprinklers basically used to spray water into the farmland, into the we can say that in the larger field, agriculture field. Fire alarms, all applications include embedded system. Telecom sector, we can use embedded system. For example, cellular phones, telephone switches, all are the examples of embedded system. Computer peripherals, printers, scanners, etc. Mouse, we can say we are using embedded system. Computer networking devices, for networking we can use gateways, routers and switches, all are used embedded system. Healthcare sector, we can use embedded system, EEG, ECG machines, okay. Banking and retail sector, we can use embedded system. For example, automated teller machines, point of sales, card readers, barcode reader, smart card readers, we can use embedded system. So there are countless applications, there are numerous applications. We are not limited to only these applications. So in a daily life, we can face many applications of embedded system, okay. So let us take some specific example of embedded system. Here I am taking bike computer. What is bike computer? Bike computer is basically used to display the time, to display the speed, distance and other parameters of a running vehicle, okay. So in Amazon and Flipkart, you can search for a bike computer. It is available from the 600 to the 2000 or 3000 according to the features. So what are the functions of our bike computer? The main function is it can display the speed and distance. The main function is that it is used to measure the speed and distance of the vehicle. How it is calculated? It is connected with our wheels, and whenever the wheels are rotating, it measure its speed and distance and display into the LCD screen. This is a bike computer. Okay. So, we can say that this is embedded system because it has a processor, input unit, output unit. What is the input unit? Wheel rotation and mode key. Okay. Mode key means we are setting the parameters, we can change the parameters in a mode key. Okay. These are the keys. And output, what are the parameters it is calculated? It will display on the output, and the output is in the form of LCDs. Okay. This is the LCD screen. Okay. So, what are the constraints of this bike computer? What are the constraints of this embedded system? Okay. The constraint is size. We have to take care of the size because larger size will not work. So, in any embedded application, it is required that the size should be less, cost should be less, power and energy, less power and low energy consumption, it is a desirable feature, weight should be less. So, all these are the constraints of bike computer, or we can say that these are the general constraints in any embedded system. So, inputs we have already discussed. Inputs are the wheel rotation indicator, mode keys. Mode keys are used to carry out the to change the parameters of any bike computer. These are the outputs, liquid crystal display. In LCD screen we can see the parameters. Okay. So, the main feature is that it is a low performance microcontroller. It uses a low performance microcontroller. So, it is of 8-bit and 10 millions of instruction per second. It has a capacity to do 10 millions of instruction per second. So, this is I am taking one of the example. There are several examples of embedded system. Okay. So, now the question is, what is the difference between the embedded system with the other systems? Other system means the microcontroller units and the general purpose center processing unit. We can say that general purpose center processing unit is also a microprocessor. So, what is the difference between the microprocessor, microcontrollers, all are general purpose systems and the embedded system? So, first let us take the example, I am taking the microprocessor. Microprocessor is basically a center processing unit. Okay. So, in a microprocessor, it is only a CPU. We have to add all the external components with the CPU. Okay. It did not have any internal memory, any ADC, DAC, timers, all are externally connected to the processor for work. Okay. So, it is defined typically as a single processor core that supports at least instruction fetching, decoding and executing. So, in a microprocessor there are 3 functions: fetching the data, decoding the data and executing the data. Okay. So, normally can be used for general purpose computing. We have all seen that microprocessors are basically used for general purpose computing, general purpose task. It can carry general purpose task only, but needs to be supported with memories and input output. Okay. So, this is the example of the microprocessor. Here it has a fetching unit, it can fetch the instructions, decoding unit and executing unit. So, it has a ALUs, register banks in a microprocessor and memory interface. So, this is a microprocessor and all the components ADC, DAC, oscillator circuit, power supply unit, all are connected externally to this chip. So, basically this is IC, this is IC. Okay. So, this is microprocessor. So, we have seen that what is microcontroller? Microcontroller basically a system on a chip. All the components we are talking about ADC, DAC, digital analog peripherals, digital peripherals, timers, counter, many peripherals, all are integrated on a same chip. So, it is called a system on a chip, computer on a chip. Okay. So, microcontroller, it is a single processor core. Okay. All the blocks, memory blocks, RAM, ROM, digital input outputs, analog input outputs and other basic peripherals to need to run a particular application, all are integrated on the same chip. Okay. So, basically it is used for control purpose and embedded applications. So it is a part of the embedded applications. Okay. So here in this diagram you can see that this is a CPU microprocessor, and this is not alone a microprocessor, not alone a CPU. All the other components needed to run a particular application: program memory, data memory, memory units, digital input output peripherals, timers, oscillator circuit, all are integrated on the same chip. So basically this is the system on chip, SoC, or we can say computer on a chip. Now what is embedded system? Embedded system is basically implemented using microcontroller units. Okay. Microcontrollers are a part of a embedded system. To design any particular embedded system, we need some processors. It may be a microcontroller, it may be a ARM processor, it may be a microprocessor, or it may be a PIC microcontrollers, etc. Okay. So it is typically designed using microcontroller units. It is often integrated into a larger mechanical or electrical system. Okay. So we can already we have discussed embedded system is a part of a larger system. So in particular larger system, there may be numerous embedded system units. So let us take example of car. In car you can say that there are many embedded system units: braking system, vehicle control system, okay, ABS, sensors, all are there are several embedded system units in any particular car. Okay. So it is a part of a larger system. This is the embedded system chip, this is the microcontroller chips. So in all the applications we can say that we are using a microcontrollers. So it works on the real time. We have already seen that main feature of embedded system is that it didn't have any delay, and it works on the real time fetching of the data, decoding of the data, and execution of the data. Okay. So this is the difference between the CPUs, microcontrollers, and embedded system. Okay. So this slide dedicated the basic difference between the general purpose computer and embedded system. In the previous slide we have already seen the some difference between the CPU, microcontrollers, embedded system. So we are compiling into this table. So first one is the criteria. Criteria is contents. So in general purpose computer, it is a combination of generic hardware and general purpose operating system for executing a variety of applications. So we can say that general purpose computing is has a general purpose hardware, general purpose operating system for executing a variety of applications. It is not used for any particular specific application, it is used for the general applications. Okay. But in case of embedded system, it is a combination of special purpose hardware. It has a special purpose hardware, not a general hardware. Okay. And embedded operating system for executing specific set of applications. So difference between these that it is used for general purpose applications and it is used for specific purpose applications, specific set of applications. It is dedicated to a particular applications. Next one is the operating system. It contains a general purpose operating system. Okay, it has a general purpose operating system, but in case of embedded system, it may or may not contain operating system. Without operating system, some applications may run. Alterations, applications are alterable by the user. It provides versatility to the system. So basically, it is used for general purpose applications. So applications the components or applications may be varied by the user, but in case of embedded system, applications cannot be alterable by the user. Once the application has been designed, it cannot be further alterated by the any user. Key factor is the performance, and here application specific requirements are the key factor. Okay. Application specific means that it is dedicated to one application and it is the key factor in case of a embedded system, along with the real time and without any delay parameters. Okay. Power consumption is more because it is used for general purpose computing. Okay. And it is used for a specific function, so it has a less power consumption as compared to general purpose system. Response time is not critical. Here critical for some applications, response time is critical for some applications. So these are the difference between the general purpose system and the embedded system. Okay. Now the next our slide is classification of embedded system. What are the various classification of embedded system? There are various classifications based upon the number of the components, based upon the number of processor, but we are talking about the some general classification. So there are three classifications of embedded system based upon the scaling size. First one is the small scale embedded system, okay, and second one is the medium scale embedded system, and the third one is the sophisticated embedded system. So small scale embedded system is basically we can say that small scale means that we are using less number of bits in a microcontroller. It has a single 8-bit or 16-bit microcontrollers, and we can say that small scale embedded systems are used for small applications like our wristwatch, microwave ovens. So small scale embedded systems use lesser components and less bit operating system. Okay, medium scale embedded systems, it has more than 16-bit microcontroller. It may have a 16-bit or 32-bit microcontrollers or DSP processors. And medium scale embedded applications are we can say that microwave ovens, machines and washing machines, etc. These are the examples of medium scale applications. Car is also example of medium scale embedded system. Sophisticated, we can say that complex embedded system. Complex embedded system has a large hardware design and enormous hardware and software complexity. For example, satellite, we are launching the satellite, it is also example of embedded system. So it has a complex hardware units, many hardware units in one application, and it has a more software complexity because each particular hardware has some compatibility of software. So there may be one or more than one software can be used in large embedded system, large scale embedded system. So you can see that in small scale embedded system, these are the PIC microcontrollers. This is medium scale application. This may be a single chip ICs, and this is our motherboard. Computer motherboard is example of embedded system. This is the large scale embedded system figure. Okay. So the next question arises: what are the various components of embedded system? There are various components. Here in this diagram, you can see that there are various components of embedded system. Processor. Processor is a main component. It is processing the data. Memory units, it may be RAM or ROM. Keyboards, peripherals, input peripherals, mouse to display the data, monitor, modems, printers, scanner, Ethernet card, all are the examples of the embedded system. So microprocessor, large memory, input outputs, output units, networking units like SPI, I2C, etc. all are example of general computing system components. Operational system. So these are the general components of embedded system. Okay. So what should be the main components of embedded system? Main components, it is a combination of hardware and software. So hardware is a main component of a embedded system, and software is also a component of a embedded system because we are embedded the software, we are integrated the software into hardware. And mechanical components to run any particular application, these are also a part of a embedded system. Okay. So and it is supposed to do one specific task only. We have already discussed that one of the main application of feature of embedded system is that it is used for one specific task only. It is dedicated to one application. It embeds a real time operating system. It works on the real time operating system, not a general purpose operating system. Real time, it didn't have any delay. So for example, I am taking example of washing machine. So in washing machine there may be a hardware, software. Okay. So hardware is a buttons, display, buzzers, electronic circuitry, other sensors. So these are examples of hardware. Software basically burned into a chip. It has a chip on the circuit that hold the software which drives, controls and monitors the various operations possible. So hardware, software, and after that what are the mechanical components in washing machine? Mechanical component to run the particular washing machine. Okay. It may be a knob, it may be a motor drivers, screwdrivers. So the internals of a washing machine which actually wash the clothes by using the mechanical components. These are the directly interface with the our particular system that control the input and output of a water and chassis itself. So hardware, software and mechanical components are example of the embedded system components. So in this particular slide we can say that there are numerous components of embedded system: input devices, okay, system application circuits, power supply units required. Reset, to reset the circuit we need reset circuit. Oscillator circuit used to provide the frequency operation to the microcontroller. Processor we need to carry out the operations by using the processor. Timers are used to control the particular events. Interrupts are used in any embedded system applications. Serial communication ports, SPI, I2C, CAN, etc. are used. Memory units, it may be a program and a data memory unit. Parallel ports are used, output ports. These are the applications, these are the various components of embedded system. These are the general components. Okay. So, I am taking the example of real time example of gasoline automobile engine control unit. I am taking this example. So, in this gasoline automobile engine control unit, you can see that there are many blocks. First one is the microcontroller. Microcontroller is a part of the any particular embedded application. So, to carry out the operation, to monitoring, to processing, to analyze the data, we need a microcontroller unit. Okay. So, below the microcontroller unit, we have a watchdog timer. What is the function of the watchdog timer? Watchdog timer is used to reset the system in case of a software fault. We have a power supply unit. V vibration is used to carry trigger the power supply unit. We have input units because embedded system we are providing the input and embedded system carry out the is providing the output based upon the variability of a input. It has a throttle position to change the parameters. It has accelerator. It has a mass airflow unit, battery, temperatures, NOx sensor. What is NOx sensor? To carry out the, if we are changing the environment parameters, then it can be carried out by using the NOx sensors. Oxygen sensors we can use, fuel pressure sensors, crank speed, cam position, clutch brake speed. Okay. These are the input parameters. So, what are the actually we are doing? We are getting the data by using the sensors from the environment. Okay. We have a physical interface unit. In physical interface unit, we are talking about the networking unit. Here it is a CAN, local interface networks, diagnostic unit to check any particular fault. Okay. Output drivers, output in the form of relays, fuel pump, oxygen heater, cam control, recirculation valves, idle control, others parameters. So, it has an injector drives unit. Okay. So, it is connected to the power stages units, ignition pre-driver, bridge driver. So, there are various components in gasoline automobile control units. So, these are the its in this slide we are mentioning its components one by one. Functions. So, functions are the fuel injection unit, air intake setting, sparks timing, exhaust gas circulation, electronic throttle control, no control. So, these are all the functions of a gasoline automobile engine control unit. Constraint, what are the constraint of this system? Constraint is that we have to maintain the cost should not be larger. We have to minimize the weight because bulky system will not work. Reliability should be high. In harsh environment, it should be reliable. Okay. And many inputs and outputs. What are the inputs? Sensors and actuators are the inputs. Sensors are getting the data from the environment, physical data, and it convert physical data into the in terms of voltage and current. Actuators, what are doing? Actuators input to the actuator is a voltage, and it convert into the mechanical. Okay. Network interface unit of for example, we can say that SPI I2C, and it use high performance microcontroller. For example, 32-bit 3 megabyte flash memory, 150 to 300 megahertz. It has a operating frequency of 150 to 300 megahertz. So, thank you everyone. I hope you have enjoyed my lecture. So, thank you.